So good morning, everyone. We are sorry for the delay. Class should start by 9 o'clock, but we are starting by 9:15 or so. So sorry for the delay. So we'll continue from where we stopped at yesterday. Chapter summary. You didn't come. Okay, okay. So maybe we should just solve our remaining two questions from the previous class. First started today. We have two more questions to solve. So let's go. Let's go to that. Let's start from there. So this is the remaining two questions. So this is the question. So people at home will be waiting for your own answer too. So let's go. We have just 1 minute to solve that first one. Number 9. It says which of these activity is often associated with disaster recovery efforts? Don't look it like that. Don't look like that. I mean, don't actually revise the question. So we'll be waiting for your answer. So the participants. So what's our answer? So A, let me see. Someone choose B. We still have like 6 people now. Should we allow you guys to talk? So participants, you can talk. Don't worry, don't chat. Just tell us the answer. We are waiting for you guys. So. Okay, maybe we should just.
The audio is not audible. I cannot hear very well.
Sorry, come again. We can't hear you clearly.
I mean, I can't hear you.
No, you just send chat so that we can proceed, can move faster. Okay, Elijah. Okay. Elijah, so you want to say something? So let's move on. You said the answer is A, right? And someone choose B from the answer. So we should go with A because we have more A. You choose B too. So you have two B's, two A's. A. Okay, you didn't attend. Here we go A. Oh yeah, now A. Automatically, you don't know it. We are in the class now. The remaining two questions. I know, you choose the same thing. So let's go with A. Let's see. We have more A's than B's. So let's go for this. So why did you choose B? So they say B is incorrect because anti-malware is useful security tool, but it's not typically associated with disaster recovery efforts. It's just anti-malware tool. So the answer is A. So let's go to number 10. So B's. Okay, that's fine. So B's, you missed the question. So number 10. What do we mean by disaster recovery? Please, everybody don't talk. She will talk first. Everybody will talk. Well, you are in the class. Yes, but I'm trying. And so read it and tell us the answer. That's so just know the question to yourself. So people at home, number 10, we'll be waiting. Okay, whichever. Don't think. Your answer is C. Okay. Answer. D. Wait, you choose D. Okay. Sad. Your answer. You're still thinking. It's just an English. You should be. It's D. D. Yeah, we are waiting for you. Let's say D. Your D. D. Let's check people at home. People don't participate anymore. So let's go with D. So the answer is D. The answer is D. So we only missed one out of the 10 questions, which is number 5. We tried, at least. That's 90 of 100. Yeah. So let's go back to our summary, chapter 3 summary. So yesterday, right, you didn't come back. No, maybe you can catch up in the summary. So we learned about access to our assets, why access is necessary, and how that access is managed. That's all about what we learned yesterday. So we said access is based on 3 elements. We said it's based on 3 key elements. We said the first one is the subject, right? The second one is the object. And the third one, the third element, is the rules. So those are the 3 elements that make up access control. So then we talk about trustworthiness and the need for access that also helps security professionals determine their access. After that, we discuss defense in depth, right? So we said defense in depth is an information security strategy that integrates people, technology, and operations capability to establish variable barriers across multiple layers and missions of the organization. That's where we talk about, putting security mechanisms, more than one security mechanism in place to fight an attack, so that if an attacker breaks one security mechanism, they will still have to fight another one, then fight another one. So a layer of countermeasure that is put in place to fight an attack. That's defense index. Then we talk about the principle of least privileges or privilege. So we say users should only have the minimum access necessary to accomplish their job. So we say principle of least privilege is that users should only be given a limited amount of access or privilege that they need to perform their job roles. So don't give them more than what they need, and don't give them less than what they need. That's the principle of least privilege. Then we talked about privilege access management and how it relates to risk and the CIA triad. We still remember the CIA triad. Right? So we say it reduces risk by allowing admin privilege to be used only when needed. So provide confidentiality by limiting the need of administrative access that is used during routine businesses. Ensure integrity by allowing authorized administrative access during approved activity, and confirms availability by providing administrative access when needed. So we also differentiated between a regular user account and a privileged user account. That's where we said the privileged user account have more access or more permissions or more privileges than normal users. They can do what normal user cannot. So with them, we talked about segregation of duties. So we talked about two-person integrity as well and how users are provisioned from being hired to terminated. So then we talked about physical and logical control and how they are combined to strengthen the overall security of an organization. Okay. So we said physical access control includes security guards, fences, motion detectors, locked doors or gates, sealed windows, lights, cable protection, laptop locks, badges, swipe cards, guide dogs, and etc. like that. That they are put in place. They are physical security appliances that you can touch, to deter someone that is trying to enter your organization. So as not to. They are physical. And that's why we mentioned fences, motion detector, doors, cable protection. They are physical. They are something you can touch. Then we talk about logical access control, also called technical control. So they can be configured or parameters stored as data, managed through a software graphical user interface, or they can be hardware settings done with switches, jump blocks, or other means. So we said logical control, they require you, giving people access through maybe your computer. It's just technical, it's electrical. So it's not physical like what you can touch. It has to be provisioned by people, by someone. Someone has to give a device permission, to perform something. So then we concluded the chapter yesterday by looking at discretionary access control, the MAC and role-based access control. Then we said this discretionary access control is a specific type of access control policy that is enforced over all the subjects and objects in an information system. So discretionary, you give people, permission to your files based on your discretion. You are the owner. So you give people who want to give access based on your discretion. The file belongs to you and you want to give that permission to people as well. So then we have a mandatory access control. So it's the policy is one that is uniformly enforced across all subjects and objects within the boundary of an information system. Here, the mandatory access control has to be configured by an admin. This is not based on someone's discretion because you are the owner and you just want to give anyone you like that permission. It's like having what's it called? So it's like having your journal, right, somewhere, and you have the lock that journal. You only give the key to people you want to let read that journal, right? Because you are giving that person that access based on your discretion. It is someone that is going to give you that access, maybe the admin of that organization, something like that. So majorly, the difference between discretionary access control and mandatory access control is the access. Who is giving who access, right? One is enforced, that all of you, whether you like it or not, we are giving you this permission based on your rule. But for the discretionary access control, it is given based on discretion. I'm the owner, so I can give that permission to whoever I want. So then we talk about role-based. As the name suggests, set up user permission based on rules. They will give you permission based on your job or your job rules in that organization. So if you're an admin, they will give you permission based on your job role. So basically, that means admin can do some things that some people cannot do. So the access that will be given to you will be more of privileged access than standard users. So access will be given to you based on your job roles. So that's the revision on that. So network fluctuating. Focus everyone. So chapter 3 quiz. So we'll be attending to the quiz now. Chapter 3. So people who participants, you have to be active. It's just pick your answer, draw it. So let's check number 1 first. So you guys will be the ones to take. That will pick the answer for you. So let's go. So which of the following is a subject? Okay. Okay. I know. D. So people at home, you answer D. Okay. Let's pick D. We have another D. So it's like everybody's taking D, but you want to say something. So let's go for D. Yeah, the answer is D. The answer is D. Yeah, it is. Because the user is initiating a request. It's trying to get something from an object. So in this case, the user is the subject. It can be a file name, it can be a fence, it can be a file. So it is D. So number 2, Leah works in the security office. During research, Leah learns that configuration change could better protect the organization's IT environment. So Leah makes a proposal for the change, but the change cannot be implemented until it is approved, tested, and clear for deployment by the change control board. This is an example of what? We actually talked about this yesterday. Not even 2 times, at least unlimited time. People at home, about 2. You must get it. Just be an English. Just English. I know you are done with it. I know. Alpha. Let's check. Type saying. Wait, the previous D or present D? Present D. Okay. D. D. So what's our answer? D. D. Everybody's D. So everybody's hitting D. So let's go for it. Wow. That's correct answer. Let's see why. The layer can make a recommendation for a change to the IT environment, but cannot enact the change without participation from another entity in the organization. That's segregation of duty. So that means no one person will carry out a job. So number 3, Duncan and Mira work in a data center at 3 feet. There is a policy that requires both to be present in the data center at the same time. If one must leave for any reason, the other must step out too until they can both enter. This is what works. Let's wait for people. Okay. People, we are waiting for you. Number 3. Number 3. Oh. See, right? Okay. Yeah, see, everybody's see. Yeah. And that's 2% integrity. So this policy ensures that a single person is not allowed, is not alone with extremely sensitive assets and reduces the potential for inappropriate activity. So number 4, that is a security analyst tasked with finding an appropriate physical control to reduce the possibility that unbadged people will follow badged employees through the entrance of the organization facility. Which of the following can address to this? Number 4, what's the answer? This one. Okay, someone is. We have A, then we have C. I have another C. So we have A, we have C. B. Okay, now this is what we'll be doing, right? So you will tell me the reason why you are choosing B. You tell me the reason why you are choosing A, C. Then we can know where to actually fight the whole thing. Another person choose A. So what's your answer? D. What's your answer? What's your answer? No, there's nothing like in between. You choose A or D. What's the answer? The answer A. You want to go with A, I know. So I choose B. You, sorry, bro, what was the answer? You know, B or C? C, sir. What do you choose? A. Okay, let's start with people that choose that Right. So let's start with that choose B. Why did he choose B? Why did he choose B? No, no, you must have this in. Okay. So to see people that wear patch. To follow them if they wear patch or not. Okay, we see to that. Okay. Maybe we should try to read the question again. Let's just try and read the question again. Because I don't know if a dog can be trained to see if people wear badge or not. That's I should be asking you. I don't know. That's why I'm asking. The smell of the badge. That's where we are. That's So they say Clyde is a security. Wait, oh, they say Clyde is a security analyst, and that analyst is tasked with finding. We are not talking. We are talking about human being here. Clyde, and he's a security analyst, and his job is to find an appropriate physical control to reduce the possibility that unbadged people will follow badge employees. So that means someone is in charge, not dog. Human being is now in charge. Human being named Clyde is tasked with that job to check people that wear badge or not within the organization facility. That's saying which of the following can address the risk? You choose D again now. That's why I said we should actually check the question. Okay, you choose A. Why did you guess? Say you guess. But I don't know, maybe that's the answer. But we are talking. Okay. Okay. Yes, used in in the bank. Yes, it's mostly used in yes. It's mostly used in an organization. It's just everybody did. But you've not wait, bro, your answer now. Okay, you choose it. Everybody choose it. Okay, answer. I choose you. So that person swallowed the answer. Said he chose you. So let's go with this. That's why I said in the exam, I said this thing last time we are having a conversation. I said you will do question and you will pick it and you will rethink that almost am I sure this is the answer? That's how they said their question. That you have to read and read the question over and over again. Because you only have the opportunity to choose once. Once you choose and you press next, you cannot go back. So it's turnstile. So it says turnstiles reduce the possibility of unauthorized personnel following behind authorized personnel, which is known as tailgating or piggybacking. Because you have to wait. So in the process of waiting, the person in charge will check maybe the badge or not. So number 5. Sinker is considering a physical deterrent control to dissuade unauthorized from entering the organization property. Which of the following would serve the purpose? Is considering a physical deterrent. Not logical now, physical. A, wall. People at home are waiting. B, we have B, we have A already. That means to chase people away. Yeah. We've seen A, we've seen B. Don't go with the crowd. Oh. You can see how crowd actually failed you the other time. B, we have two B's. We have two A's already. We have two B's, we have two A's. No, you only have one option. Answer, right? The meaning of anything. You have the groups. You have the groups. D. D, right? B, okay, let's check. Number 5, A. We have B. We have A. So we've been seeing A and B. The answer. B. Why did you choose B? Result tape. Okay. Same thing. People that choose A, why did you choose A? Okay, someone choose A. It's physical. Yes, it is terrorist. They can decide to jump. A sign. Physical. Something physical. So everybody is choosing. We should go with B and A. So we have more B's than A's. So let's check the answer then. Let's solve the fight. So you get it there. So razor tape at the top of a fence or walls is both intimidating and acts as an excellent deterrent. So that means the person has fence already. Then he has. Hmm? But it's physical to deter people. That's we said this yesterday. They can enter, but it will be more difficult than just ordinary fence. Yes, that's what we are talking about. So number 6. Which of these combinations of physical security controls share a single point of failure? So single point of failure is part of your system that if it fails, the whole system will be down. That if it fails, the whole system will be down. If you are picking D, you will give me the reason why you are picking D. Okay, so let's hold on. Let's wait for people at home to gaps and fences to make sense now. Have you now? That one to make sense. That if it fails, the whole system will be down. Yeah. Okay, we have answers from house. Someone choose D. You choose D. So what's the answer? You don't know. You are not picking any. You must pick. You are not picking any school. D. You are still. Okay. So what did you choose? D. You just came, right? So why did you choose D? Yes. Okay. Okay. So what will now happen? Until it was gathered. What about the camera parts? We have high illumination light. Okay. 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 You just say why? Okay. Wait, so hope it's not because I said it makes sense the other time. Okay. Okay. What's that? If I'm not out. What's going on? Maybe you want to try to. So we should go with, okay, let's check people. We have 1D, we have A. Okay, you know, tell us the reason why you choose A. Mm. Okay, guards and fences. You choose C. You choose C. Why? So you can get. Okay. We go with it. Go with it. So we are saying if that thing fails, the whole system will go down. Why guards and fences? Go with it. The answer is D. The answer is D. Because both lighting and cameras requires power. So a power failure in any of those, they are gone. So they say guides and fences represent defense in depth. Although an attacker can scale the fence, the guards still operate and may catch the attacker. If the attacker can elude the guards, the attacker's team must get over or through the fence. So it's D. So number 7, actually presents a user ID and a password to a system to log on. Which of the following characteristics must the user ID have? The user ID. What must the user ID have? C. Let's wait for people at home. All of us see. Everybody. Are you sure? Can it be C? Are you sure? C. What's the answer? C. Answer C. Okay, A. We have A and we have C. Confidential. There's nothing confidential in. Okay, let's check the answer. But I will help you out here. I'm picking C as well. So identity assertions must be unique to differentiate between various users. So no two entities in an organization should have two identities, like same identity. So it must be unique. So number 8. Number 8. So much you see. Mathematical. A. 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 We have another A. So let's check. The answer is A. So passwords, like all authenticating elements, must be kept secret from all but the user that owns that password. So it must be confidential. So number 9, Derek logs onto a system to read a file. In this example, Derek is what? At least someone is initiating and someone is. And we know that someone that is initiating the subject and the other person that is given the subject. So in this case, Derek's log onto the system's read file. To read, not to give. Okay. Yeah, that's the answer. Subjects are entities that access objects. So number 10. C. C. Someone said B. Someone said B. Who said B? You. Why? You just C. So let's check the answer. That's the correct answer. That's the correct answer. So I think we get everything. Okay, we missed something. We got everything. So we got everything. That's where it is. Okay. Okay. Yeah, that they have in that organization. For that organization. That is unique to that organization. Yeah. That's your question. So that's 10-10. So this will be sent to the group. Don't think we. So this is the third time that we are trying to fight the other time. So it's a one-way spinning door or barrier that allows only one person at a time to enter a building or pass through an area. And we talked about Unix yesterday as well, as an operating system that is used in software development. So user provisioning is the process of creating, maintaining, and deactivating user identity on the system. So for people that, yeah, you get the matter. And that's the segregation of duties and role-based for people that didn't come yesterday. Should we move on? Or you want to check this out? Let's check it out. Oh, yeah. Yes, sir. Yes. Then, can we move on? Can we? So these are the key takeaways. So the access is based on three elements: the subject, the object, and the rules. Then defense intent. So these are the examples of useful access control. So chapter 4. Let's start our chapter 4 today. So network security. So networking is what allows the internet to connect nearly everyone and everything. We can't do without networking. So networking is the interconnection of two or more devices for the purpose of sharing a resource or resources. So why most see computer networking, computer networking as a positive. Criminals routinely use the internet and the networking protocol themselves as weapons and tools to exploit vulnerabilities in the system. So for this reason, we must do our best to secure the network. So we'll be reviewing basic networking components, threats and attacks to networks. And also we'll be learning how to protect network from an attacker. So network security is often a specialty cybersecurity career. However, all information security professionals need to understand how network operates and how it can be exploited in order for it to be secure. So in this chapter, we'll be talking about network security concepts, how to recognize common networking terms and models. We'll be identifying common protocols and ports and their secure counterparts. We identify types of network, cyber threats and attacks. We discuss common tools used to identify and prevent threats. We will identify common data center terminology, recognize common cloud service terminology, and also we'll be talking about how to identify secure network design terminology. So let's dive into networking. So computer networking. They said a network is simply two or more computers linked together to share data, information, or resources. That's the purpose. That's the reason why they are connected, to share data or information. So to properly establish secure data communications, it is important to explore the technologies involved in computer communication, from hardware and software to protocol and encryption. We gave ourselves an hint about encryption yesterday, so we'll be talking more about it today and beyond. So you need to familiarize yourself with many details, standards, and procedures here in this module. So we have types of networks. There are two basic types of network. It is more than two anyways, but they want to talk about two here. So there are two basic types of networks. We have a LAN and we have WAN. So basically, a LAN stands for a local area network. It's a network typically spanning a single floor of building. This is commonly a limited geographical area. So a LAN has a limit to where it can go. So here we are using this MyFile. It's a router. It can't go beyond this building. That's a LAN. As for the WAN, it's a wide area network. It's the term usually assigned to the long distance connection between geographically remote locations. So it can, go beyond states, it can go country to country, all over the world. Example is our internet that we use. That's an example of wide area network, the internet. So these are the network devices that we have. We have network devices. The first one is hub, right? So hubs, so basically we not actually dive into all of this like deeper, right? So we just want to actually talk about them, but there are more to them. There are more to hub, switch, router, right? So hubs are used to connect multiple devices in a network. It's like your extension box where you plug your charger, like this. The hub serves like this extension box. You just come there and plug your device. So basically to extend the network. So they are less likely to be seen in business or corporate networks than in home networks. Hubs are wired devices and are not as smart as switches or routers. So hub is not as smart as switches or router. So basically, a hub, there is something in the networking we call collision domain. You understand? That's why I'm smiling, because you know what I'm talking about. So, like I said, we'll not actually be diving like deeper into it, but there are more to them. So the only difference between hub and switch, or basically hub, is that hub is like a one-way traffic, a one-way route, that if someone is coming, it's either this person that is coming have to wait, or they will have an accident. It's just a one-way communication. That's a hub. So, and most of the time, if they use it in the network, in a corporate environment, there used to be something we call collision. The packet that someone is sending will collide with the packet that another person is sending, and they will have to go back to where they are coming from. So then, like I said, we won't go back because you'll be. So let's go to switch. So rather than using a hub, you might consider using a switch, right? Or what is known as an intelligent hub. So basically, switch, works like a hub works. Normally, something similar, but it has more functionality built into it. Switches are wired devices that know the addresses of the device connected to them and route traffic to that port or device rather than transmitting to all devices. So when you plug a switch and you want to send a message, if you want to send a message to A, if you send it to switch for the first time, it will send the broadcast to all the devices connected to it, just to know their location, their address number. So that next time, if you want to send anything or a packet, you just specify that device address that you are going to instead of hub. Hub doesn't have that. Hub is just forward to everybody on the network. Either you want to listen to that packet or not, you must have it. Even if you don't want to, a hub will give it to you. But a switch will break that barrier, I mean. So if you want to send something to A in switch, you can specify that I'm sending it to this person, but you cannot do that in hub. So even if you are sending a sensitive data in hub, everybody connected to that hub will see that sensitive data. And that's one of the reasons why they are not using hub anymore, because it's not secure. But a switch will not do that. So offering greater efficiency for traffic delivery and improving the overall throughput of data. Switches are smarter than hubs, but not as smart as routers. So switches can also create separate broadcast domain when used to create VLANs, which will be discussed later. Okay. Let's see how it goes. So let's talk about router. Routers are used to control traffic flow on networks and are often used to connect similar networks and control traffic flow between them. So let me just cite an example. Right? If you want to communicate from, like, have you ever sat down one day and think about how we'll be chatting people in London, and we'll be like, if I chat this person will just receive that message. Is it that they are using magic or something like that? So basically, we talked about LAN network the other time, right? That can only go beyond this, our room, right? So if you want to do something, for example, let's say this room is a company on its own. Let's say ABC company, right? And your company wants to communicate to another branch somewhere else, maybe outside this state, right? The only reason you can do that is by using router. Switch cannot do that for you. Like we said, switch actually perform the way us perform. It's just to connect devices, to extend network, right? But they cannot go beyond your LAN network, this small geographic location. But if you want to communicate wider, like you want to communicate to people in Ibadan, you will need router. We also call that router gateway. It will lead to anywhere you want to go. It's just like a border to all the states. There's a border between Osun and Ibadan. So router will be the one to communicate people in Ibadan and to people in Osun. Without router, you cannot perform that job. So routers can be wired or wireless. So basically, this is an example of router. It can be wired or wireless. I can connect multiple switches. Smarter than hubs and switches, router determine the most efficient routes for the traffic to flow across the network. So router will determine how your network is going to flow so as not to delay your traffic. It's just like a Google map. They will find the best path to your location so as to move faster. So if you are sending anything, router will be the one to determine a route to go so as to give you faster delivery and to get your packet to where you want it to go. When I mention packets, just think of it like a package, that you are sending a package to someone. Then we have firewall. Firewalls are essential tools in managing and controlling network traffic and protecting the network. Like we said yesterday, that firewall controls traffic, the inflow and the inbound and outbound traffic on your network. So if your network is, okay, if you configure your network explicitly to block some traffic from coming into your network, right? Firewall will be the one to do that for you. If you don't want some staffs in your company to send a packet or a package outside your company, you can actually go to the firewall and tell the firewall that anybody going to this address, don't let them go, block them. Or anybody that is coming from outside the world to our network, block them, don't let them in, except the ones we allowed you to do. So if they allow some IP address to enter their network, those are the IP that we enter the network. Those that are banned will not be able to enter the network. So a firewall is a network device used to filter traffic, like I said. So it is typically deployed between a private network and the internet. That is between your office and the outside world, the internet. As we all know, the internet is not secure, it's not safe. There are a lot of people, bad people on the internet. So firewall will be the one to actually, filter the bad people out from the good people coming into your network. But it can also be deployed between departments. So within an organization, firewall filter traffic based on a defined set of rules, like I said, also called filters or access control lists. So like I said, access control list, I think I mentioned this yesterday. Access control list is just a list of authorized people that you map into that firewall. So the firewall have or has the list of people, the authorized people that are permitted to your network, and the list of unauthorized people that are not permitted to your network. So if unpermitted network is coming or traffic is coming to your network, so the firewall will check the access control list to see if this person coming to your network is part of the authorized people. If they are part of the authorized, it will let them into your organization or your network. But if they're a bad guy, they are bad guy and they are part of access control lists that are specified that these people are bad guys, then it will block them, it will not let them in. So then let's talk about servers. Server. So a server is a computer that provides information to other computers on the network. That's why we talked about object and subject the other time. So in this case, server is the object. And you're trying to, collect something from that server. You are the subject. Some common servers are web servers, like our websites, right? Where a lot of things are stored in. Our email servers, print servers, database servers, and file servers. So the server is just a centralized location where information are stored. Then a client can then go to that server to collect an information that is stored in that server. So if you want video from YouTube, you have to log into the YouTube servers to take that video out. So it's just a centralized location where information are stored, or data are stored. All these are by design, networked and accessed in some way by a client computer. The servers are usually secured differently than workstation to protect the information they contain. So like we said, server is just like an asset to an organization. So they must put more security into it. Then we have endpoints. So endpoints are the end of a network communication link. They are the computers, our smartphones, anything in our IoTs. So they are endpoints because they sit somewhere trying to get information from a server. That's what makes them an endpoint. So one end is often at a server where a resource resides, and the other end is often a client making a request to use a network resource. So it's like a client and server, right? So the client in this case is the endpoint because you are trying to initiate a resource from the server. So you sitting at the end, you are the endpoint trying to access the server. That makes you an endpoint. So your phone, your laptops, anything you might think about can be an endpoint. So an endpoint can be another server too. Desktop workstation. It can be our laptop, our tablets, mobile phone, or any other end user device. And these are other networking terms that we use. First one is Ethernet. So we have a lot of Ethernet, but I think they just named one here. So we have Ethernet IEEE 802.3. So it's a standard that defines wired connection of a network device. So they are the one in charge of all these wires that we use to connect our devices together. So this standard defines the way data is formatted over the wire to ensure disparate devices can communicate over the same cable. So prior to this time, like I said the other day, normally HP cannot communicate to Dell prior to this time. iPhone cannot communicate to Infinix prior to this time. So it is this standard the IEE that now comes together and solve the barrier that, okay, it doesn't make sense for this vendor to not be able to communicate to this vendor. So let's come up with something that will make all of them to communicate or to interact. Then we have device addresses. So we have media access control, MAC. So this MAC will be found in layer 2 of the OSI layer. So it's basically mapped to switch. The MAC address we mostly found under switch, where they say we are going to dive deeper as the class goes on. Move on, So every network device is assigned a media access control address. This is the example. So that means your laptop, your network interface card has their own MAC address. The wireless device there has its own MAC address, So almost all the devices has their MAC address. So the first 3 bytes, that's 001302. That's the first 3 bytes. So in a byte, we have 8 bits in a byte. And that 8 bits is equal to 255. So they increase by the double from left to right. So that means we have 1, we have 2, we have 4, we have 8, we have 16, we have 32, we have 64, then we have 128. So a byte has 8 bits. And that bit is 255. We still talk about it when you get to IP address. So the first 3 bytes or 24 bits. So the reason why it is 24 bits is 8 plus 8 plus 8 plus 8, making 16 plus 8, making 24. So, okay, we will talk about all of those in IP addressing. So, of the address, do you know the vendor or manufacturer of the physical network interface? So, that first 3 bytes actually speak to an organization that makes that device. So, IEE, we assign numbers to all the companies or manufacturer that is manufacturing hardware devices. So they will assign a number to them. So that means this 001302 belongs to one manufacturer, maybe a Dell or an HP. So anytime you are saying that, you will know that, okay, this particular number belongs to HP. So no 2 devices or devices can have the same MAC address in the same local network. Otherwise, an address conflict will occur. There's no 2 devices that you will see that they will have the same MAC address. It will never happen. It may attacker know the way they can actually forge that they will use your own MAC address so that anything that I'm sending to you will be coming to them. They will change their MAC address to your own MAC address. So anything that is coming to your side, go to their site. Then we have IP address. Is this everything they talk about? Why MAC addresses are generally assigned in an interface firmware. IP host associates that addresses with a unique logical address. What's this? IP host associate that address with a unique logical address. Okay, I will talk about this. So this logical IP address represents the address within the network and can be useful to maintain communication when a physical device is swapped with new hardware. Examples are 192.168.1.1. That's an example of an IP address. And that's an example of IP before IP address. So like I said, that 182 is 1 byte. So that means that 1 byte has a maximum number of 255. It can go to 255 and the minimum number of 0. So 192, then we have classes of IP address. I don't know. Maybe we still talk about it. So we have classes of IP address. We have class A, we have class B, we have class C, and we have class D IP address. So this example is class C IP address because of the first octet. And the first octet is 182 because class C starts from 191 to 223, I think. So there is a way. So classes, they have their range of IP addresses that you use to specify them, and you can only specify these using the first context. But in this place, this is class C IP address, right? And we have this other IP address. This is IPv6 IP address. The first one is IPv4 IP address, and the second one is IPv6 IP address. That's how IPv6 looks like. So IP address, we should talk more about IP address. Or if they don't talk more about it before the end of the class or the module, we try to expand more on IP address. This is a networking at a glance. So this diagram represents a small business network. The lines depict wired connection. So those lines are wired. Notice how all devices behind the firewall connect via the network switch, and the firewall lies between the network switch and the internet. So basically, this switch connects all these workstations or endpoints. Like I said, they are just like an extension box that you can connect cables to or wire to. So the server too is connected to the switch. The WAP, the wireless access point, is connected to the switch. But without the router, they are still within the LAN network, local area network. They are not going anywhere outside the organization. But immediately you introduce a router, you can go as far as anywhere you want to go. But before the router, you are still within local area network. So the router is introduced, and now they can access the internet. And these two, they are the endpoints, but they are wireless. They are not connected using wired. So they are wireless. They are collecting information or service from this wireless access point. And this wireless access point is connected to a switch. So this switch is the one giving the wireless access point its service. And all these laptops are collecting that service from the wireless access point. So the network diagram below represents a typical home network. So we call it SOHO, small office home office, SOHO. So the network diagram below represents a typical home network. Notice the primary difference between the home network and the business network is that the router, firewall, and network switch are often combined into one device supplied by your internet provider and shown here as the wireless access point. So here, our normal home network, right? We see that most of the time we don't need the switch, the physical switch and the routers. This is all we need. This MTN wireless. And this MTN wireless is connected to some switch, or maybe some masts connected to this area. So this is yes, that's what they are. So if you actually go to this POP, the point of preference, that's what we call it, networking. There is router somewhere in that area that they connect to this mast. So this mast is basically serving like a wireless access point to feeding people. So you don't have to go there and connect wire. So you just have the service using wireless, maybe through electromagnetic waves, some sort of, things like that. So in your home, you don't need to buy router, you don't need to buy switch, you don't need to buy firewall. So you just need wireless access points to be able to browse. Then we have networking model, right? So we have many different models, architecture and standards that exist that provide ways to interconnect different hardware and software systems with each other for the purpose of sharing information and accomplishing joint or shared tasks. So computers and networks emerge from the integration of communication devices, storage devices, processing devices, security devices, input devices. Basically, the reason why we have network is just to, to get information as quicker and faster as we want. We just want to connect to YouTube and download video. Instead of buying cassettes or the physical, we just want to connect using internet, right? To make life easier for us. So translating an organization's security need into safe, reliable, and effective networks system starts with a simple premise. The purpose of all communications is to exchange information, like you said, and ideas between people and organizations so that they can get work done easily and faster. So those simple goals can be re-expressed in network and security terms as such as provide a reliable, managed communication between host and users. Isolate functions in layers. Okay, we still talk about that. Use packets or package as the basis of communication. Also, we can standardize routing, addressing, and control. We can allow layers beyond internet networking to add functionality and be vendor agnostic, scalable, and resilient. So let's talk about this OSI layer. Okay, I think they talked about this. So let's just check this diagram out still. I think they talked about it. I wanted to talk about it before. So we have application layer. Those are the upper layers. Where you interact with your devices, where you chat, your WhatsApp, that's the application layer. That's the upper layer. The session layer is part of the application layer. And then we have the lower layers. We have transport, where package are then transferred from one location to another. We have network, like your IP, where you connect to the internet using your IP address. We have data link, where you send a packet using the MAC address of the switch. Then we have physical layer, like all these are wires and cables that we use. So we still talk about it. So in the most basic form, a network model has at least two layers, which is the lower layer and the upper layer. So the lower layer is often referred to as the media or transport layer, and is responsible for receiving bits from a physical connection and converting that bit into a frame. So there's something called PDUs, protocol data units. I don't know, maybe we'll still talk about it. So basically, it will convert a bit, like the signal coming from your wires, right, to a byte, to something the computer can understand, like one and zeros, right? So frames are grouped into standardized sizes. Think of frames as a bucket and the bit as a water. If the buckets are sized similarly and the water is contained within the bucket, the data can be transported into a controlled manner. Route data is added to the frames of the data to create packets. In other words, a destination address is added to the bucket. Once the buckets are sorted and ready to go, the host layer takes over. Okay, I will summarize everything. Let's just continue. So the upper layer, known as the host or the application layer, is responsible for managing the integrity of the connection and controlling the session, as well as establishing, maintaining, and terminating communication session between two computers. So upper layer is where you connect. The Zoom meeting that we connected to, of course, in session layer, whereby the connection will be established. And if we are to, off the Zoom meeting, it will still pass through session layer, right? Because that's where connection actually takes place. It is also responsible for transforming data received from the upper layer, which is the application layer, onto a format that any system can understand. They are talking about presentation layer. I'm not sure it's listed there. Okay. So, and finally, it allows applications to communicate and determine whether a remote connection partner is available and accessible. That's where we talk about three-way handshake, whereby you have to send, a message to someone at the remote site to ask if the person is online. So if the person is online, then they will reply that, okay, fine, I'm online. Then the third person can say, okay, fine, let's communicate there since you are online. Call it three-way handshake. It's acknowledgement, sync arc, and acknowledgement. Then OSI model. The Open System Interconnection, OSI protocol, was developed to establish a common communication structure or standard for all computer systems. Like I said, before now, different vendors cannot communicate with each other, right? So until IEE comes, and this is one of the protocols that makes it possible for different vendors to communicate with each other, right? So the actual OSI process was never widely adopted, but the theory behind the protocol, the OSI model, was readily acceptable then. The OSI model serves as an abstract framework. That means something you cannot see, logical framework or theoretical model for how protocol should function in an ideal world on ideal hardware. So thus, the OSI model has become a common reference point against which all protocols can be compared. So the connection, the internet, the browsing we are doing on the internet, they must follow this OSI layer, the 7 layers of the OSI, they must follow them. So the OSI model divides networking tasks into 7 distinct layers, like we said. Each layer is responsible for performing specific tasks or operations with the goal of supporting data exchange. In other words, network communication between 2 computers. So the layers are always numbered from bottom to up. So they are referred to by either their name or their layer number. For example, layer 3 is known as the network layer, or you can call it network layer, or you can use the number like layer 3, and layer 2 will be the switch. So we talk about this. Okay, basically, let me just go back, right? So from bottom to up, this is the physical layer where you see all your wires. You can call it layer 1, or you can call it physical layer. This is the data link layer. You can call it layer 2 or data link layer. This is the network layer. You can call it layer 3, where you find your IP addressing. This is the transport layer, where you find your TCP IP connection, TCP or UDP, where this is where the packet is being transferred from one place to another. Then you have your session layer, which is layer 5. You have your presentation layer, or you can call it layer 6, and you have the application layer. You can call it layer 7. And they perform different tasks. So the application, presentation, and session layer, that's layer 5 to 7, are commonly referred to as data. However, each layer has the potential to perform encapsulation. So encapsulation is the addition of header and possibly a footer trailer. So we have header, we have footer. So in the header, that's where you put, basically encapsulation is just like you put so many things inside one container and you close it. So all those, that means these 7 layers is enclosed, is encapsulated into one, package. So when you transfer that package, right? Okay, let me do it like this. Let's assume you have 2 users, right? So one user needs to go through this process, maybe by sending a message to you, right? So the person will send the message in the application layer, which is layer 7, that's hi, alpha. Then, like you said, the computer doesn't understand English except 1 and 0, right? So presentation layer will format it and present it to the person, right? Because you said you don't understand. As if you see 100111111111000, you cannot understand. So presentation layer will convert it or format it to the language that you understand, English. The session layer is where the connection will be established. where two of you will be established. Like you can now chat, all of us can chat, you can establish connection. Transport layer is where the package you are sending is where it is carried out using TCP or UDP. So network layer is where your address is, the address you are sending the packet to is using your IP address. So if you are sending a packet to my system, I will give you the IP address of my system so that if you are transferring or you are trying to communicate to my system, we transfer using my IP address, then it can come to my system straight. Then we have data link layer where we have MAC address, the MAC address of your laptop or system. Then we have physical layer, those wires. And all these layers too, they have their own protocols that actually speak to them, how they talk, how they must talk. But you don't need that. It's for networking students. But they just want you to understand something. And we've understand this already. Okay. I would say 5, 6, 7, 1. Okay. Fillers. Footer. Yeah. Okay. So encapsulation is particularly important when discussing transport, network, and data link layer. That's layer 2 to 4, which all generally includes some form of header, like you said. So at the physical layer, which is layer 1, the data unit, the signal, that the wire is transferring, is converted into binary. For example, 01, 01, 0111, because that's the only language that the computer understands. And sent across physical wires, such as the Ethernet cable. So let's map some common networking terminology to the OSI model. An image, files like JPEG or PNG, is at the presentation layer, like I said, right? That's where you can interact, where you can see it. It's in the it's in the presentation layer that will present it to the application layer, right? Logical ports such as NetBIOS are the session layer. So NetBIOS is where your computer is starting to use. So we have protocols like TCP, UDP. They are the transport layer. So the difference between TCP and UDP is one is more reliable than the other, right? So maybe we still talk about it. Router sending packets happen at the network layers. So we see routers at the layer 3 of the OSI layer, right? Which is the router. So switches, bridges, or wireless access points that are sending frames are activities that occur at the data link layer. So you will find your switch, your bridge, or your hub at the data link layer, which is layer 2. So encapsulation occurs as data moves down the OSI model from application to physical. As data is encapsulated at each descending layer, that means the packet will be sent from application, then to go to presentation, then to session, then to transport, then to network, to data link, and to the physical. As data is encapsulated at each descending layer, the previous layer header or payload and footers are all treated as the next layer payload. So the data unit size increases as it moves down the conceptual model and the content continues to encapsulate. The inverse action occurs as data moves up the OSI model. So basically, if you are sending, right, you will send from application, you will go from application, presentation, session from 7 to 1. So if you are receiving, so that data will be converted or will be in a reverse case. That means you are starting from physical to data link to network to transport to session to presentation, then to your application where you can see what the person is saying. But if you are the one sending, you are chatting, right? So it will start from where you can interact without OSI, like your phone. or your WhatsApp. That's the application layer, because you can interact during that domain. Then to move to presentation layer, then to session layer, then to transport. So for the receiver, at the receiver end, it will start from layer 1, from physical layer to data name, to network, to transport, to session. Then the session will convert it to what you can understand, and you can see this. You can see the chart that someone is sending to you. So if you are sending, you go from 7 to 1. So from the receiver side, it will be from 1 to 7. Yes, so we have TCP/IP. We have transmission control protocol, or internet protocol. The OSI model wasn't the first or only attempt to streamline networking protocol or establish a common connection standard. In fact, the most widely used protocol today is TCP/IP, and it was developed in the early 1970s. The OSI model was not developed until the late 1970s. So the TCP/IP protocol, or protocol stack, focuses on the core functions of networking. This is how it works. This is the architecture of TCP/IP. We have application layer, and this application layer, like you said, defines the protocol for the transport layer. So application layer will be the one to define protocol that the transport layer will run on. So the transport layer will permit data to move among devices. It's where the packet will be transferred from one device to another. Then we have internet layer. Internet layer is where we create or insert packets, like our IP, right? Then we have network interface layer. This is where data moves through the network, how data moves through the network. Okay. So we said the most widely used protocol suite is TCP/IP, but it is not just a single protocol, rather it's a protocol stack, those 7s that we shows the other side. So it's comprised dozens of individual protocols. Like I said the other time, each layer has their own protocols as well. So TCP/IP is a platform independent protocol based on open standards. However, this is both a benefit and a drawback. TCP/IP can be found in just about every available operating system, but it consumes a significant amount of resources and is relatively easy to hack into because it was designed for ease of use rather than for security. So when they are developing the TCP/IP, they didn't put security in place when they started then, because they don't know that some people will explore the opportunity and start hacking people or hijacking people, emails. So now at the application layer, TCP/IP protocol include telnet. It includes FTP, file transfer protocol. It includes simple mail transport protocol where email are sent. And it includes domain name service, DNS, like your www. anything. So the two primary transport layer protocol, TCP/IP, are TCP and UDP. So TCP is a full duplex connection-oriented protocol. When we say full duplex, that means transport or connection can occur in two different connections or two areas. We have one wire that we use to send and another wire that we use to receive. Just like two-way traffic, right? Whereby people can be going like this and other people going like this. So whereas UDP is a simplest connection protocol. So basically, simplex connection protocol, just it's one-way connection, whereby a connection will be sent in just one way, right? So that means the connection will pass through a single wire. So that means someone is sending, the person that is going to receive is going to wait. It's not like full duplex, whereby you can call and someone will say hello, you too, you can respond and be like, hello, what's up? But in simplex, it's just one way, just like radio. someone will be talking and you can't respond. Even if you are cursing the person, it doesn't even hear you. So that's an example of simplex. The radio that we use is an example of simplex. And the example of full duplex is our phone. You can talk, then another person can talk. You can receive and you can send at the same time. So in the internet layer, ICMP, Internet Control Message Protocol, is used to determine the health of a network or a specific link. To determine the health of a network or a specific link. So Internet Control Message Protocol is used by ping, traceroute, and other network management tools. So basically, this tool, ping or traceroute, is used to check if the remote connection is off. So you can, okay, hold on, let me just show you something. What I mean by ping. So, same. So if you do ping this IP address, this is Google DNS. In order to check if the DNS is up and running, so you just do ping, then you enter. Then this is basically saying that the DNS is up and running because you are getting reply from this IP address. If this IP address is not up or the DNS is not up, you will not get any reply. So if you want to trace routes, so basically trace route is you trying to know how that packet went or comes back to your network. So let me show you. Do trace routes. Okay, trace routes. So this 192.168.0.1 is one hub or hub. Maybe basically that's like one router. So that means that connection, when we ping it from here, it jumps to one router closer to us. Maybe this router, I don't know. Then from there, it jumps to another router, then to another router, then to another router until it reaches, someone is waiting there. Sorry, you can drop the chat, then we can read it. 11, it's 11 already. Just type, then we read it. Sorry, I did tell you. Right. So basically, this are the hub that DNS passes through. The IP that we ping, these are the router that it jumped just from one router to another router to another router until it reaches the destination where the DNS is located. So I know you will not understand, but some will understand. That's why I don't want to actually put it back. Anyways. So basically, ping is just to confirm if the remote network is up and running, which we can see from here. That the IP address or the person that we are trying to reach is up, because we can see the reply from that person, right? And this is the time to leave. So it takes this, byte, 42 milliseconds, to connect to that device. And okay, the packet that is sent 4 times, which is 1, 2, 3, 4, and it's received 4 times as well. And it lost no connection, 0 loss. So approximate round trip times in milliseconds. So minimum is 27 milliseconds, which is this. And the maximum is 45. But the average, if we do 42 plus 27 divided by 2, we get this to give us the average of that. So this is where we reach the DNS that we are trying to ping. But before we even reach this DNS, that ping passes through this, router, this hop, this IP, then jump to this IP. You can see this different classes of IP. This is class C IP address, this is class C IP address. Right? So it jumps from this open WRT.LAN. Maybe these are, I don't know. Then it jumps to another router, then to another router, to another router. It lost a connection here, but it jumps to another router. So this is basically the function of router, is to define a path that a packet is going to go through. So that's that about that. Oh, I think it's 11 already, 11:02. So basically, maybe we'll continue from here next week, Friday. But okay, sorry. Okay, but there will be a session after this class, right? That is starting 11:15. 11:15, yes. Just like we had it last week, Saturday. So you can ask a question. And if anybody have question at home too, you can ask their question. Oh, sorry, I didn't know that you didn't see that. So we have to. Let me see. Because they have to see. Okay, I've actually closed it. Yeah, I can only see. Sorry, this is the ping that we used. And this is Google DNS, domain name service. Then we use traceroute. Basically, traceroute and traceroute, they are both correct. But traceroute is used in Unix, like inside our Linux, Ubuntu. That's where you use traceroute. You use traceroute using Windows. No. They are open source operating system. I think it's now owned by Microsoft or something. It's Mac is their normal, they have their own, which is Mac. Mac OS. As we are still seeing the same IP, that means it's still going through, but not necessarily it goes through this. It can jump from, like I said, a router will be the one to determine the path. If the router, if this next router thinks that the more faster route is to pass through this router, then that's where it will jump to. That may be maybe 65 or 64, or maybe it will take more time to actually get there. Then the router will decide to go to use this IP because maybe it's closer, or, to where you are going, to your destination. So now trace is completed. I don't think the other one ended the other time. So as the class actually goes on, maybe we'll be doing some hands-on using our Linux as well, not just Windows alone. We're using our Linux as well. So that's all we wanted to ask. Most of them don't even start that. Yes. It doesn't change. Yeah. Do you think it's possible to understand the MAC address? Yes, but I said it the other time. Yes. So, like, criminals, let me call them criminals. They are not cyber attackers. Criminals, they know how to do it. Maybe next class, maybe I will show you. Sure. I'm not a criminal. I'll just show you how it is done. So, yeah, no, I don't even put criminal. Don't put criminal at the end. So, so basically, I'll just show you how it is done. Maybe in our next class. So there is a way you can, change or use someone else's MAC address, and also you can dynamically change your MAC address. I don't want to actually tell you what happened, but you guys blocked me from your LAN the other day, but I find my way. I later used it. So basically, there are ways to actually do things like that. So I just saw that I cannot class it. Like, am I using your? I was like, okay, even if you not give me the data, just tell me that this thing is not for everybody. But the fact that you think you are smart and can block me out of the network. So I just showed them. And that day, I wasn't even meant to download anything much, but eventually, I later downloaded something. So next time, just tell me that the network is not for you, then I'll stop. So basically, that's it.